You cannot scroll through your feed today without, like, someone claiming an artificial general intelligence is arriving next Tuesday. I mean, it has almost become background noise at this point.
Oh, absolutely. It's everywhere.
Right. But when Andrew Ng speaks up, and for you listening, he is one of the key architects of modern AI, the pioneer who founded Google Brain. When he says the entire industry is basically grading its own homework and failing, you really have to pause and look at what is actually going on under the hood.
Yeah, and that skepticism is exactly the foundation of our deep dive today. We are looking at a recent, highly detailed interview with Ng, where he just strips away all of the Silicon Valley marketing hype surrounding AGI.
Because it's gotten pretty out of hand.
It really has. The reality we are operating in right now in 2026 is that the term has been completely co-opted. I mean, it is being used to drive fundraising rounds rather than describe a genuine technical milestone.
Which is pretty concerning for the industry as a whole.
Exactly. And that is incredibly dangerous for the trajectory of the technology because, inflated expectations eventually collide with reality, and that risks triggering an AI winter where investment just completely freezes up.
Okay, let's unpack this and ground it for you, the listener. The historical definition of AGI was always pretty straightforward, right? It was an AI that could do any intellectual task a human can do.
Right. Any task.
But Ng is arguing that because we are hitting walls technically, companies are quietly moving the goalposts. So he proposes a different metric to cut through all this noise, the Turing AGI test. And this isn't like the old 1950s chatbot test, is it?
No, not at all. Let's look at the actual mechanics of his new test. It's a multi-day onboarding experience.
Okay, so how does that work?
Well, you sit an AI down, you give it a standard laptop, a web browser, a Zoom account, and, access to the company Slack. Then you ask it to function as a skilled remote professional for several days.
So just throwing it into the deep end of a normal office job?
Exactly. Can it handle the sheer ambiguity of a chaotic corporate environment? Like, can it adapt when the server suddenly goes down or when two coworkers give contradictory instructions in a really messy Slack thread?
Let's make this tangible because I love this example. If I hired an AI today to run my company's marketing email inbox, how exactly does it fail on day 2? Because on day 1, I give it the standard operating procedure, and it probably writes 50 perfect replies.
Right. Day 1 is fine. But on day 2, say a vendor emails you with an invoice in a slightly corrupted PDF format, and they CC a new account manager whose name wasn't in the AI's original briefing.
A total edge case.
Exactly. A human reads the context clues, figures out the PDF is just a standard invoice despite the formatting glitch, and welcomes the new manager. The current AI, operating outside its immediate training distribution, just breaks down.
Oh, wow. So what does it actually do?
It either hallucinates a response that totally insults the vendor, or it triggers an endless loop of error messages trying to parse the PDF, or, and we see this a lot, it just silently crashes because it doesn't possess the generalized problem-solving framework to navigate an edge case.
So it completely lacks common sense, which makes me wonder. It's like calling a really fast calculator a mathematician just because it solves equations quickly.
That's a great way to put it.
If companies keep lowering the bar to claim they've reached AGI without passing a rigorous, messy real-world test like that, doesn't the word just lose all meaning, like calling everything blue?
It does. What's fascinating here is that redefining AGI might help these companies hit arbitrary PR targets, but it completely misses what the public actually cares about. We care about human-like intelligence that can actually do our jobs.
Right. But that presents a massive disconnect in the data we see every single day. I mean, AI companies are constantly publishing these benchmark charts showing their models hitting 90–95% on complex reasoning tests.
Well, the benchmarks, yeah.
If a real-world multi-day test is the only valid metric, why are we still pretending these static benchmarks matter? If these benchmarks are so flawed, why do we keep using them? Is it just because they are easier to grade?
That is exactly why. We use them because they are objective, they are cheap to run at scale, and they are mathematically gradable, but they mask what Ng calls a jagged form of intelligence.
A jagged form of intelligence. I like that phrase.
Yeah, it means AI is great at some things and just awful at others. Like, if you ask a frontier model to solve a complex differential equation or tell you who won the 200-meter freestyle in the 2012 Olympics, it will absolutely crush a human.
Because it just pulls the data instantly.
Right. It uses vector embeddings to perform factual retrieval and pattern matching flawlessly. But ask it to write a nuanced research report evaluating the cultural impact of that swimming event, and it completely falls apart.
I've experienced this exact frustration. You look at a 95% benchmark score, then the tool fumbles a simple calendar scheduling email, and you feel like you're losing your mind.
You're definitely not crazy. Real human work has shades of gray. AI crushes those black and white tests, but fails at human nuance.
But isn't part of this just data contamination? Like, if I memorize the answers to the SAT before taking it, I'm going to score a 1600. I'm not a genius, I just saw the test beforehand.
That is a massive part of the illusion, actually. These models have ingested so much of the internet that the benchmark test questions, which often reside in static datasets on GitHub, are already embedded in their training data.
So they're literally just reciting the answers.
In many cases, yes. But even beyond contamination, there is the fundamental issue of static versus dynamic evaluation. A static benchmark is a fixed target.
Whereas a human judge is dynamic.
Exactly. A human judge probing an AI in a real-time conversation will intuitively hunt for the AI's blind spots. We instinctively test for weakness in ways a standardized test cannot.
We naturally find those jagged edges. Okay, so if the benchmarks are a mirage and true generalized intelligence isn't coming next Tuesday, what is actually driving the economic value today in 2026?
That's the million-dollar question.
Because we know the old playbook, just scraping the entire open internet and throwing exponentially more compute at it, is hitting a wall. The synthetic data degradation alone is a huge problem. We can't just scale our way out of this anymore.
No, we can't. And the shift we are seeing, and what Eng is heavily focused on, is the pivot from raw scaling to agentic workflows.
Okay, agentic workflows.
Right. Instead of trying to build a monolithic, godlike brain that autonomously knows everything, developers are taking highly capable models like Claude 4.5, Gemini 3, or the GPT 5.1 and 5.2 series and giving them highly structured tools to perform narrow, complex tasks.
So we are talking about autonomous systems built explicitly for, like, checking tariff compliance or medical diagnostic assistance or deep legal discovery.
Yes, and we are starting to see models like Deep Researcher operating with slightly less scaffolding, running a thought, action, observation loop to decide on its own when to search the web and when to summarize.
Here's where it gets really interesting, though. We're giving AI all these tools, but there's a catch, right? Because it's like giving a chef too many utensils at once. They just get confused.
That is a very accurate analogy.
Like, I see enterprise companies loading up their model context protocol servers, giving the AI access to Slack, Jira, the company database, a weather API, just 50 different tools at once. And then the AI just freezes or hallucinates wild commands. Why does giving it more capability make it mathematically dumber?
It all comes down to how context windows actually function. You have to think of the context window not as a hard drive, but as the AI's short-term working memory.
Okay, short-term memory.
These models use an attention mechanism to weigh the importance of every single word and tool description against your prompt. So when you dump 50 complex API schemas into that context window, the mathematical attention matrix just dilutes.
Oh, I see.
Yeah, the model has to spend so much computational power just distributing its attention across all the tools available that it loses focus on the actual problem you asked it to solve.
It literally crowds out the cognitive space required to execute the task. It forgets the primary instruction because it's staring at a menu of 50 shiny buttons.
The math bears that out completely. To make an agentic workflow reliable enough to run 10,000 times perfectly for an enterprise, you have to drastically limit its toolset. You have to meticulously manage the context window and put blinders on the AI.
So we are spending millions of dollars and countless engineering hours building these elaborate harnesses, essentially trying to force an artificial brain to behave reliably in a corporate environment.
We are.
Which begs a massive question for me. Why can't the AI just learn on the job naturally, the way a human does? Like, if I hire a junior marketer and they mess up an email sequence, I correct them once, they remember it, their brain adapts, they don't do it again.
Right.
Why can't the AI do that?
You are highlighting the plasticity puzzle. This is the gaping chasm between human biological plasticity and an AI's brute force architecture.
Okay, unpack the biological plasticity part for us.
Well, our biological DNA is incredibly elegant. It's a very small amount of code, but it generates a highly general learning algorithm, your brain, that can dynamically rewire its synapses in real time. Like, you can learn to paint, and then tomorrow you can learn advanced calculus, all without forgetting how to speak English.
Like how a human child learns to walk after just a few falls.
Exactly. Compare that to how an AI needs millions of reinforcement learning simulations just to grasp basic physics.
I want to clarify something here because I think there's a lot of confusion about what happens when you quote-unquote, teach an AI something new in a chat window. Wait, so right now when an AI, quote-unquote, remembers something, it's just writing text into a file, right?
Correct.
It's not actually rewiring its brain. Isn't that a massive bottleneck?
This raises an important question, and yes, that distinction is absolutely vital. Current models do not fundamentally update their weights, their core neural structure, while interacting with
At
you.
least read the log.
Exactly. They rely entirely on text-based agentic memory, which means they are just reading your previous conversation history inside that crowded context window we just talked about.
Wait, so why don't developers just let the models update their weights dynamically on the fly? Wouldn't that solve the context window limit and make them actually intelligent?
If you try to update the neural weights of a large language model with a single new piece of information on the fly, you trigger a phenomenon called catastrophic forgetting.
Catastrophic forgetting. That sounds, well, catastrophic.
It is. The mathematical adjustments required to incorporate that one new fact using backpropagation ripple through the entire billions parameter network. So an AI might successfully learn your company's new refund policy, but those global weight updates might randomly destroy its ability to conjugate verbs in French.
Or format Python code.
Exactly.
It essentially overwrites fundamental knowledge to make room for the new data. That is just wild.
It really is. To avoid catastrophic forgetting, you have to freeze the model, gather millions of new examples, and run a massively expensive reinforcement learning process in a simulated environment.
So you can't just teach it on the fly.
No. N points out that this brute force approach costs millions of dollars in compute power. Meanwhile, biological plasticity is virtually free. From a pure economic standpoint, brute forcing a narrow task costs millions, whereas hiring a human who can adapt immediately is just better economics.
Which brings the economics directly to your immediate career trajectory, listening to this. Because if the compute cost of brute forcing AI memory is unsustainable, and human biological plasticity is vastly superior for adapting, we have to look at the workforce realistically. What jobs are actually in danger right now?
N maps this out very clearly based on what we call the automation threshold. The rule is essentially AI won't replace you, but a human using AI will.
So what jobs are crossing that threshold?
The jobs facing immediate replacement are those where nearly 100% of the daily tasks operate within a highly constrained, predictable environment. Eng specifically points to call center workers, language translators, and voice actors.
Because almost 100% of the role can be automated.
Exactly. In those domains, the current AI architectures, even without true plasticity, are capable of handling the entire workflow end-to-end.
But for complex, multifaceted roles like lawyers, financial analysts, radiologists, it's a vastly different story, right?
Vastly different. The AI might automate the 30% of tasks that involve raw pattern matching, like document discovery or initial medical scan analysis, but it absolutely requires a human to leverage AI for the remaining 70% to navigate the messy, unpredictable stuff.
And this is creating a massive crisis in our educational institutions, isn't it?
Oh, absolutely. Universities are notoriously slow to adapt, and they are fundamentally failing to address this new ratio. They are still churning out graduates trained for the entry-level jobs of 2022 jobs that consisted entirely of that 30% pattern matching work.
And those roles just don't exist anymore.
They're gone. Consequently, there is an immense talent gap in the market. Companies are desperate for AI-fluent marketers, recruiters, and CFOs who know how to operate these complex agentic workflows.
So what does this all mean for you? Let's use an analogy. It's like if you're a carpenter refusing to use power tools. The hammer didn't replace the carpenter with the nail gun did.
That is a perfect analogy. Or think about the concept of centaur chess. Back when IBM's Deep Blue beat Garry Kasparov, everyone thought human chess was just dead.
Right, the machines had won.
But then they created centaur tournaments, where humans paired up with AI. And they found that a mediocre human player using a mediocre AI could consistently destroy a chess supercomputer. They covered each other's blind spots.
Wow. So the AI handled the perfect brute force tactical calculations, and the human applied the strategic intuition and biological plasticity.
Exactly. And that is the perfect framework for the modern knowledge worker. If you are a programmer or a lawyer today, you aren't competing against an autonomous machine. You are competing against the centaur.
You are competing against the human who is leveraging AI to execute the brute force tasks.
Right, which frees up their biological plasticity for high-level strategy. The productivity chasm between the centaur and the traditional worker is widening at an exponential rate.
Okay, but if my entire future as a centaur depends on having access to that AI counterpart, we need to talk about who actually controls the technology. I mean, training these frontier models requires billions of dollars in specialized hardware and data centers.
It's astronomically expensive.
Right. With only a few companies having the massive capital to train frontier models, aren't we already hurtling toward an oligopoly anyway?
That is the most pressing geopolitical and structural risk in the industry right now, and compares this danger directly to the mobile phone ecosystem.
Where iOS and Android basically run everything.
Exactly. If you want to build a mobile app today, Apple and Google are absolute gatekeepers. You have to abide by their rules, pay their taxes, and they can just revoke your access overnight. A significant faction within the AI community is fighting aggressively to prevent that same gatekeeping dynamic from taking hold of human intelligence.
And the primary weapon against that is the open source or open weights movement, which is a fascinating dynamic because while the US giants push proprietary models, a lot of the absolute best open weight models we're seeing right now are actually coming out of China.
And highlights this global balance impartially. You see, when a company releases the open weights of a highly capable model, it fundamentally changes the power structure.
Because you aren't just renting it.
Exactly. It means you aren't just paying for access to an API hosted on someone else's server. You receive the actual matrix of numbers, the finished artificial brain, and you can run it on your own local hardware.
Oh, like a hospital. They could take an open weights model, fine-tune it on highly confidential patient data without ever sending that data over the internet, and build a custom diagnostic tool securely.
Yes. It completely democratizes the intelligence. It means any small developer or local business can build an agentic workflow without asking a tech giant for permission.
Or renting their brainpower indefinitely.
Exactly. It ensures that the baseline of artificial intelligence remains a decentralized utility rather than a private toll road controlled by a few massive corporations.
Okay, we have covered some massive tectonic shifts today. Let's pull the pieces together for you. The idea that a godlike AGI is arriving next week is an illusion driven by flawed benchmarks and marketing hype.
Right.
True, generalized intelligence that can pass a multi-day real-world Turing test is likely decades away because we haven't solved the plasticity puzzle or catastrophic forgetting, but you cannot ignore the technology.
You really can't. The era of agentic workflows is here. The immediate reality is that you must become a centaur fluent in directing these AI tools to remain viable in the workforce.
But beneath all the technical mechanisms and economic strategies we've discussed, there is a profound philosophical layer to Neng's perspective in the source material.
There is. Before he ever founded Google Brain, and actually spent years diving into neuroscience literature, hoping to map artificial neural networks directly onto the human brain.
And what did he find?
His ultimate takeaway was remarkably humbling. Despite all our scanning technology and medical advancements, we actually have almost no idea how human consciousness or biological learning truly operates.
We don't even understand the source code of our own intelligence.
We really don't. We are building massive statistical engines that mimic our outputs, but the internal biological spark remains a complete mystery. And because of that, Eng leaves us with a necessary warning.
What is it?
We shouldn't look for happiness, meaning, or fulfillment inside artificial intelligence any more than we look for happiness in the electricity that powers our homes.
It's just a tool.
It is an infrastructure of productivity. Purpose comes from within and from our connections to other humans.
Which leaves you with a final provocative thought to mull over. If we do continue down this path, and in 30 or 40 years we actually solve catastrophic forgetting,
Right.
if we crack the code of biological plasticity and build an AI that can perfectly mimic our general learning algorithm, passing that multi-day Turing test with ease, and suddenly it can perform all of our economic labor for us.
Yeah.
If we can no longer define our self-worth by our daily productivity, our job titles, or our output, where will you look to find your human purpose? We started this deep dive talking about the murky metrics used to measure intelligence. But it turns out the most challenging landscape of all isn't inside the machine.
No, it's not.
It's figuring out what it truly means to be human when the machine can finally do our jobs.